Let's see what happens when we make our soap film 1/4 of a wavelength of blue light thick. I start at the front face of the soap film at a 0, and the back face is at a maximum of the blue. So we'll bring in our blue wavelength of light in phase. They come passing through the transparent soap film. We'll stop when both waves are exactly on the front edge of the soap film at one of the folds, one of the gaps in the cards. You remember what to do. Fold back the front one, representing a reflection from the front surface. Pull through the excess. Because it was going from air to water, I flip it over. Then I look at where the back one is. It's at the peak here. It's 1/4 of a wavelength of blue. And I fold the card back at that maximum, pull through the excess, and when I look at the light coming out, I find out that the peaks and the valleys match up. So at 1/4 of a wavelength of blue thick, bright blue light reflects from the front surface. Let's see what happens with a super thin soap film. I'm going to represent that by a string. So I'll bring in my in-phase blue waves, and the front and the back of this soap film are exactly together. So I'll do the same thing. I'll fold back the blue from the front surface, pull through the excess, and flip it over because it's from the front surface. Then I'll fold over the light from the back surface of that super thin soap film, pull it through. I lined it up so that the budding joint between two cards lines up with the soap film. And look at this. Whenever there's a minimum of one reflection, there's a maximum of the other, and so on, so that the reflection from a thin soap film for blue light is completely canceled. No blue light reflects. Let's see what happens when I do the red light. I line them up. They start out together, beautifully together. I pull them through, passing through the soap film, until I get them where a budding joint between two cards lines up with the soap film. I then do the reflection from the front surface, pulling the excess light through as if it passed through, flip over the one from the front surface, and then I flip over the one from the back surface, pull through the light that's just going to pass through, and notice that the red wavelength also completely cancels. So a very thin soap film has no reflection for any color of light at all. And that's why when we look at a very thin soap film, it appears completely transparent. Now you have the tools to investigate what happens when different colors of light reflect from different thicknesses of soap film. We investigated soap films that were a full wavelength of blue light thick, a 1/4 wavelength of blue light thick, and very thin. And we did it for blue light and red light. Now you can try a soap film that's half a wavelength and blue light thick. Predict first what you think will happen when blue light comes in to that film, and then do the experiment and find the result yourself. You can also make a model of green light with a 4x6 card. This models the 600 nanometer wavelength of green light in a 6 wide card. And that allows you to take red and green and blue light and put them through soap films of any thickness and find out what colors will reflect and what colors will be canceled, and therefore understand the colors in real life soap films that you see in a bubble.